I'm here to introduce Grace Hummell. She should be a face that most of you know, right? Your husband says that. So she grew up in Baltimore County, and she started out at American. She didn't stay at American. She came over to UMD and got her degree out of ENST Wildlife. I was lucky to be her advisor through that whole adventure. And graduated in 2016.
I think so.
As undergrad, it's okay. And then she went to work at USDA, and then she came back to get a master's at ENST, collaring mice. That was a lot of fun, following them around. And then we conned her into staying on for a PhD. And my PhDs are notoriously too big and too long. So she is here, she's almost done. She's wrapping it up in this year. And she's going to present one chapter of her 3 to 4 chapters that we have. Thanks.
Yay. Thank you. So my name is Grace, as Jennifer just said, and I'm here to talk to you today a little bit about my dissertation, and it is now lovely called Tangled in Ticks. So ticks and tick-borne diseases is an expanding issue, and I think we talk about it a lot within the United States, but it's a global problem. Not only with just disease in humans, but I think people forget about livestock as well. And this becomes relevant when we start talking about our new invasive tick. And I actually, before I get started, I brought ticks to my own talk, sponsored by the USDA. I'll leave them up here. I don't think I should pass ticks around the room, but after the talk, you can come and see these ticks. We have the invasive tick here too that I'm going to talk about today. So for tick-borne diseases, I try to look at the most recent, I guess, best guess from literature of how much it costs per person in the United States. Lyme disease is our #1 vector-borne disease in the United States, and this estimate from 2022 said it was about $2,000 per person, which is absurd, and I think most of America cannot afford that unless you have good health care. It's a complex issue. This comes down to management and how do we handle management. I'll go into the tick ecology itself and why that's complex, but then who's in charge? Is it the individual when you get the tick bite? Is it your county? Is it your state? Is it your federal? And then because it is a talk about ticks, I always usually like to talk about diseases really quickly, or diseases to know. So again, Lyme disease, I think all of us have heard of it, hopefully here in Maryland. If you just moved to the East Coast, Lyme disease. Lyme disease is the #1 vector-borne disease in the United States. In Maryland specifically, we're looking out for Babesia. Babesia does a co-infection now with Lyme disease, and it's a malaria-like disease, and it's pretty scary. So that's up and coming in our state. Everyone's great. And then I threw up here alpha-gal syndrome, another thing to watch out for because ticks are expanding and we're having more and more Lone Star ticks. Alpha-gal syndrome, it makes you allergic for meat and all animal products for 7 years, which is kind of scary if you're a big meat eater, and then all of a sudden you go into anaphylactic shock. So cool. That's spreading. All right. So ecology of ticks and why they're so complicated, and and I guess why I've been here for 4 or 5 years now for my dissertation. Ticks with the landscape have a lot of relationships. They spend 90% of their time on the landscape, and they're expanding due to fragmentation. It's hotter, it's humid, climate change. Can we say climate change nowadays? I think so, but that's what's happening on the landscape. From the landscape, they need a blood meal from wildlife species. This is just a blood meal. They'll get dispersed through wildlife species, and this will help with population. But within the wildlife species itself, and I like this Osfeld et al. Graphic, they have their own complex system. So depending on what kind of wildlife species you have in your park or in a larger scale, can change what ticks are there. This is also where they pick up pathogens. Next is a human interaction and how we dictate where ticks are and the prevalence of disease. I really like this paper by Halen et al. This was done in Belgium, and it talks about how, as humans, we dictate the landscape or change it via fragmentation, and that can change how prevalent a disease is or how prevalent a tick is. And then finally, this graphic from the CDC, I think, if you worked at the USDA, Laura and I should probably print this out and put this in our homes. But just talking about when do you get the disease and the life cycle of ticks. And I highlighted that nymph stage because that's the most likely stage that you're going to get a tick-borne disease. So within my own project and looking at how do I set up my dissertation and where is this going to be the most impactful to look at where ticks are on the landscape, I decided to look at this idea of likelihood of exposure. So we can look at where ticks are and then who's interacting with them. Sorry, my other good friend just walked in there. So for this particular part of my dissertation, I wanted to look at this likelihood of exposure within this interface between suburban and urban areas. And this is because the interaction of humans is a lot greater, you have a lot more people, and then there's more green spaces in these areas. And so this was the first attempt at my dissertation. Really, I just want you guys to get heart palpitations looking at this. Like, it's so complex that it was hard to break down. And then we decided to walk away with it with very simple goals in mind. First being landscape patterns, to just see what ticks are doing on the landscape, keeping it kind of simple, hopefully. And then next would be looking at wildlife community and their composition in these urban green spaces. And then finally, if we can bring it all back and look at the relationship of ticks, landscape, disease, and wildlife communities. And so for my overarching dissertation and just the general methods that I did, I had a camera trap array. It was about 98 sites. And this was to look at density and abundance of larger mammals. I did tick sampling, which I'll talk about a little bit later. And then small mammal trapping. And if Carson's on Zoom, a little shout out to Carson, which was his master's. This is what we got. This was a massive project and turned into a massive project. It ran through 3.5 years. We are still chugging away at the million camera photos that we have. It had about 50 interns. I see Spencer's in the crowd, and I know some people are logged on, and 4 graduate students. And this is just a big thank you to everyone that has put on this project because it is massive and we've collected so much data. So thank you to all the interns. All right, so from all this data, I narrowed down my research objectives to 3 main chapters. The first being different ways of modeling ticks and landscape components. Second being urban green space composition and configuration and specific wildlife hosts. And then finally, that relationship piece of bringing it all back together. And so today, I'm really just going to focus on this landscape portion because this ends up being the backbone to the rest of my modeling and my chapters. So to model ticks on the landscape, what I needed to do was a species distribution model. And species distribution models, the simplest definition is just looking at species across the landscape and pulling in environmental variables to see where they are. And this is done through many different methods and across many different disciplines. Ticks in particular are hard to actually do this. They have many different issues with the data. Ticks are scale dependent, and from the literature thus far, I see a lot of regional looks at ticks, but not necessarily a local look at ticks. And this is really due because we don't have enough fine scale data, but luckily for Maryland, we do have fine scale data, so that's why I was able to do this. Next, ticks are heavily clumped, and so they're going to be inherently autocorrelated, or you're going to have a lot of zeros in your data set. Data for ticks is not uniformly collected. So this means that each study that is done, everyone does something differently. So if you wanted to collaborate and do maybe a species distribution model with ticks outside of your initial study, you might have issues. And then of course, if you're gonna bring in those host dynamics. This is just the tick distributions that I have found in literature. So the most popular is generalized linear mixed models and then maximum entropy. MaxEnt has been around quite a while for wildlife. And the takeaway that I just want you gather from this slide is that there is no one way to do this, which made it kind of complicated when my initial question was, what are ticks doing on the landscape? So now I have to look at a bunch of these models and see how well they do. And so common ways, and I brought my other little prop outside of my petting zoo of ticks. This is our tick drag. Some of you might be triggered by seeing this. So tick drag and flagging is 2 ways to do this, and you walk across the landscape dragging this giant sheet. I'll leave it here. And depending on your research question, it changes the scale and how you set up your transects, and that becomes part of the problem of uniformity across these literature or species distribution. So the first way is just stopping every 10 meters or more and collecting an XY. Another way to do it is stopping upon first encounter, where people will time themselves, or summing across the transect. For my own methods, I decided again to do this in relation to my cameras so I can get at that chapter 3 and bring everything back to that chapter 3 of relationships. So to do this, I had to do a circle plot. And then I set up 10-meter XY locations. So if we got a tick, we would write down its XY location. If we didn't get a tick, it would get a 0 at each one of these spots. And then I ran this for those specific months for ticks. So that's March through October. The models I decided to look at was MaxEnt, or maximum entropy, generalized linear mixed models, or GLMM, and then a stochastic partial differential equation model, which is a GLM, but it incorporates a mesh, and I'll talk about that in a second. So MaxEnt, I decided to do it to be directly comparable to literature. There's a lot of literature that uses MaxEnt, and then of course there's a lot of literature on ticks that use MaxEnt. MaxEnt only uses presence data, so it's very attractive to a lot of people, especially in the tick world, that only get presence data. This also has an option to weight your sampling effort. So if you have something like ticks and I have them in one clumped area, I can call it's a bias MaxEnt and weight where those are. The spatial component of MaxEnt, it does continuous raster surfaces, and I will show you what those look like, and you have to supply them to the MaxEnt model directly, and then it will output an index of habitat suitability. Next, I did a suite of GLMMs. I'm going to say generalized linear mixed models, I think was probably easier, but again, to compare to literature, this is nice because you can have flexibility, and I think a lot of us use GLMs in our own research where I can use presence, count, and absence data. And then the spatial components with this is making a random effect. So in my own project, I did this with parks, and then I take the predicted response values and extract them to a spatial grid. So in SPDE, it's new, and what it does explicitly is model autocorrelation, which is great for ticks and why I chose this model. It also is flexible with scale. So what it does spatially is you create a mesh, and this mesh goes over a continuous surface, and you can pull out those expected values there, and then you can dictate how big you want that scale of that mesh to be. So examples of what this looks like, MaxEnt, you have your points with your ticks, those are all my stars, and then you will have your background points that are randomly generated. GLMM, they look like stars, so it's either my counts or my ones for where the ticks are, and then zeros in all the places that people stopped and then didn't get a tick. And then a mesh, and I really try to get a high resolution of a mesh on my map, but hopefully this suffices of what this looks like. So I created a fine scale mesh directly over where my XY points are, and then a larger, broader scale mesh in areas that I didn't have XYs. So for my model setup, the goal of this chapter was to look at ecology through all of these models and see how well they are at predicting ticks on the landscape, and then also at model performance to see if one was better than the other with this tick data. And so today I'm really just going to focus on the ecology, but know that we are about to do the model performance part of this research. And so for the ticks themselves, I split them up with all ticks, native ticks, and then by species, and you'll see why very soon for this lovely Longicornis here, who messed up my project a little bit, but it's okay. And then also for this, I did detailed landscape covariates, because again, the end goal is to get to that chapter 3, and so if we can pull out important landscape variables now, I can bring them into my other chapters. So just again, a little bit more about setup. MaxEnt, present only data. I had about 2,000 background points on some of these, a little bit more if I had more tick data within them. My GLM, I decided to do a binomial, a negative binomial, and a zero inflated negative binomial, or a ZIB. My random effect was by park. For my SPDE, I also decided to do a zero inflated negative binomial. And just very quickly, if you're not familiar with a negative inflated zero binomial, it is a regression that has two distributions in it. The first being that zero inflated part, and that's the probability of a count being there. And then the second portion of that is the negative binomial, that if that is present, this is the possible count. And you'll see as I go through these slides that I have some Z's and Y's on covariates, and that's because they go to either part of that SIM model. For both the for all the GLMs, including the SPDE, which is GLM, I did them in InLaw, and InLaw is just a package in R that looks at spatial data. And then for model selection, I looked at DIC and WAIC. So the very large list of covariates, I started off thinking about what do ticks need or basic needs for ticks. And that was things like temperature and soil and humidity and anything that was directly related to ticks themselves. Next, I broke things down into edge and fragmentation, which is important for ticks, especially our native ticks, but also really important for our small mammals. And here's a long list of what I consider to be edge and fragmentation in my covariates. And then finally, kind of harping back to that Halen et al. Paper about connectivity in the landscape, and if we can break down our parks to see how connected they are. These are the list of covariates that I thought would meet that. And some of these I know seem a little unfamiliar. If you don't know what interspersion and juxtaposition is, it's an index that is done in FragStats. And all these that I've highlighted is basically quantifying the landscape and the landscape patterns to get a little bit more details. And so what do they look like? Just to give you some visualization. So here's Rock Creek Park. And I want your eyes to kind of track these two green spaces here. And so this is interspersion. It's a metric that just looks at how complex an edge is. If your edge is right against a couple of different patch types, it would get closer to 100. And you'll see those forest patches are 0 because there's not a lot of edge and there's not a lot of differences in patches. Contiguity, am I saying that right? Yeah, is one of the metrics I pulled out to get at how cohesive a landscape is or how connected a landscape is. If it gets closer to 100%, it's a more connected landscape. Rock Creek is a very linear park, so you can see that it's not very connected. And then finally, edge density, how much edge is around this park in this green space. If it's 0, that means there's no edge density, so in the middle of the park. And then if it gets closer to, I guess it's infinity of how complex your edge is. And I really wanted you to look at those different spaces in the forest because all of those FragStat metrics are inherently correlated. And so I had to do a correlation test. I threw out just a few, but then others we decided might have ecological meaning. And so that's why I kept them in the model because they are doing different math or they have different values. So next I ran a univariate WAIC test, and instead of having a giant table of all of those numbers, I just pulled out the very specific ones and showed you where they landed in that rank. I also included a null model, so I had those 15 covariates, included a null model, and really I just wanted you to see how often edge density and soil came up on top for my all tick model. I did this same process for my native ticks, and I'm doing this right now for all of my species models. And it's the same deal of soil being important. And I think I might have tricked you all to coming to a soil talk. So I'm excited for all the soil scientists here to tell me if I'm on the right page or not. Okay, so after taking this, oh yes, sorry. The only one that was a little bit different and pulled out different metrics, which I'll talk through a little bit, was this part of my zero inflated negative binomial, which was the count portion, and it looked at, I think it was distance to trail was more important than some of these metrics. But next I ran all combinations model, and the reason behind this, again, is we just wanted to see how these models performed, and also with the ecology behind them. So when we actually run these for the landscape of ticks themselves, we're gonna be a little bit more thoughtful and not just fully run an all combinations model. But these were the top models that popped up for each one of these. So for my all ticks, just going through the binomial and negative binomial and their effects graphs down here. What was pulling out pretty interesting was soil. They really didn't like silt loam, or there was more of a negative a relationship with silt loam, but then between the two models, loam and then loam crossing the 0 was different. So I thought that was pretty interesting. So next for the all ticks and all combination models, the zero inflated models, this is the ones that popped up as the best, having the best WAIC score and what this looks like. So pretty similar in some of these relationships and means that are being pulled out. Random effects by park, they were pretty similar across all of the GLMs. And you can see Rock Creek is pretty low, and it's because I only got 14 ticks there. So that is why. For the native ticks, same setup. I did in all combinations and looked at the best WAIC score for how those models came to be. This, because of the native ticks, they pulled out a little bit of this, more of the same covariates, with soil also being the top across both of these. And I have some maps, and I'm going to talk about these a little bit more. So again, something that was pretty interesting, and I'll talk about this when I have my maps up, is edge density for my native ticks has a positive relationship, but if we go back to my all tick model, it had a negative relationship. And then again, looking at the random effects by park, Sligo Creek actually had the most of our native ticks that we sampled there, and that's why that's the highest. All right, so MaxEnt for model selection. MaxEnt has this kind of built into the program, and it's similar in the aspect that you take a look at the contribution and importance of the covariate in the model, and then you have to go back through, remove anything that is unnecessary or lower than 1 in this case, and rerun the model. Model validation, so this is the upcoming plan. So what we plan to do for the model validation and looking at the models themselves to see how well they perform, we're going to withhold a subset of data and then rerun the models. Cross-validation or a k-fold validation is already done in MaxEnt. I will have to do this in GLM, so I'm going to do that after I run this first set of models. And then for comparing just across the board, we decided that we're going to run some of these models with the same covariates, probably soil as the same covariate across all models. But today we're just focusing on the ecology. All right, let's get into some maps, everyone's favorite part. So I am going to just take a snippet and look at Cabin John Park that is here. This was one of our tickier parks. And so up first is Cabin John and MaxEnt, up first is MaxEnt and Cabin John Park. And this was the predictive map that went into my all ticks model. And just as you start looking through these maps, because I have a bunch, know that it's not saying that it's 100% chance of a tick being in the red. This is all relative to what landscape covariates I put in. So it's more of saying out of all of the habitat types, this is probably the best place for ticks. Not that you're 100% going to get a tick. And this was the very first model that I ran for this chapter. And at first I was like, oh, this is really cool, but the ticks seem to be everywhere. And pretty quickly I realized that is because of our invasive tick, which is here. You should all take a look if you can. So this is the longhorn tick, or the longicornis tick. They were first discovered in 2017. I think one of us and the USDA found the first one in Maryland, so we're in the history books. They prefer different habitats, so that's why some of these models you'll see it's pulling different things. They are not necessarily dependent on host species, meaning that it's just females and they can all clone themselves. So they still need to feed, but they don't have to have a male and a feeding to drop and lay eggs. And then right now they have negative implications on livestock and wildlife. I think they still are biting humans, but not to the frequency that I think black-legged ticks do. And they're starting to carry diseases, so it's getting scary. Anyway, so this was my prediction map. It felt like there was so many ticks living in so many different types of habitat. This was the map of just my native ticks, and this is what I expected. For ticks to be right on the edge, just not really in the neighborhoods or those open spaces, and avoiding the river that's running through Cabin John. And just as these models run, here is my longhorn predictive map, and you can see that it's a little bit more general, or the model is pulling out a little bit more generally of habitats that they could be in. All right, so for all ticks, GLM, and my binomial, this is my predictive map that I made. And what is cool about this, and I think really where it's getting at, is longhorn ticks and how they drive this model. Longhorn ticks, I guess, with this, were really found in the middle of this park in this open area. And so they're showing more of an edge density having a negative effect. And within literature on ticks, especially our native ticks, edge density is supposed to have a positive effect. So as I was running through these models, and as you'll see through some of these maps, it was like, oh no, the longicornis are driving everything. And then next is my native ticks of the same binomial. And with this, ecologically, what's happening are these two parameters that I pulled out. So interspersion is how complex an edge is, and then cohesion. And what this is telling me in looking at this map is they do like it more on the edge, but there's some interface where if it gets too complicated of an edge, or if it gets too of the interior of the woods, or too cohesive, I guess, the ticks might not necessarily be there. So the next is my negative binomial. This one was, for all ticks, pretty heavily affected by my soil covariate. I thought this was really interesting, and in this map itself, you can almost see like where the soil planes of the roster that I got out, and that could just be me reprojecting it back on the roster map itself. Negative binomial again for my native tick model. Silt loam is again very unpopular, I think, for the ticks. And we discussed like what was happening with soils, and I'm sure some of the soil scientists will chime in, but silt loam is getting closer and more wetter to clay. And so ticks like a happy medium where it's hot and humid. So we're suspecting that they're avoiding places like silt loam because it's too wet for them to be. And then finally, or not finally, sorry, this is my all tick model for my zero inflated negative binomial model. And again, this is looking at probability of a tick being present, and then you overlay that with, if it's present, how many of ticks. And at first, you're probably like, Grace, there's so much red. Does that mean there's ticks all over this neighborhood? The answer is no. It is because of the longicornis being so heavily right here and pulling out that open parameter that it's telling me in this model that that proportion of forest has a negative relationship within there. And then of course, edge density as well has a negative relationship. So the next step with this graph and reprojecting it, I'm going to take out where the ticks actually are and kind of remove this background noise of this projection. So my native ticks and my zero inflated binomial model. This map and the one before was pretty similar at pulling out the probability of where ticks might be. But then this is also affected by at least the count by one of my covariates, and this is trails, and you can see they're avoiding the trails. And then again, there's an inverse relationship with just my native ticks that we found was pretty interesting, that they like a proportion of forest, so they are in the forest a little bit more, and then edge density is coming into play and not being a negative relationship anymore. So for the SPDE, just a reminder, this graphic is what it looks like when you first overlay, or after you pull out that mesh. And the mesh is showing a hot spot of ticks of where they might be in comparison to just the GLM with the random effect. And so the first one I did was an all ticks model. And I really, when I did this, and this kind of drove home that we're gonna probably do a paper on the longicornis ticks of how much they're changing this model. Rock Creek Park is this park in the middle here, and Rock Creek Park is a giant wetland, and our native ticks don't necessarily like wetlands. So when I first made this graph, I was like, oh no, are they in the wetlands? And it's because of longicornis tick liking that open spaces or having maybe a little bit more general use. And then also within Sligo Creek Park, they're in, if you know anything about this area, this is a golf course. So it was telling me that they like these open areas, maybe people's lawns, golf courses, and wetlands. This is what I expected, and this is all of our native ticks. And so Rock Creek Park, they really don't pop up in this model very much in the SPDE. And then they're pulling out in Sligo Creek of where I expected them to be, like right in the woodlands there. And we also see this in the random effect map of the GLMs. So they're still saying kind of similar things, but you're getting a little bit more detail with the SPDE. Okay, and so this is an all-tick example of the SPDE looking at Cabin John. And what's interesting about this, and when I talk about a little bit more detail through the SPDE, it's showing me some interesting ecological information. So these bottom circles that I have here is showing that there's a higher probability of a tick being there and then maybe a higher count. Again, we're looking at right here, ignoring all this noise because of the longicornis. The top part is telling me that there is a higher probability of ticks being there, but not necessarily a high abundance of ticks. And so that gets you to start thinking of why maybe some areas have a high probability and high abundance versus some areas that is a high probability and a low abundance. And these sites specifically, and when I start doing my chapter 2 and looking at the wildlife portion, some of these sites, especially the lower circle, have a lot of activity of wildlife. And we got large numbers of small mammals and a lot of numbers of animals on cameras. Versus the top part of Rock Creek there, it has some good tick habitat, some wildlife, but it's not as luscious and there's not a lot of understory and there's just a minimum leaf litter. So some summaries of models, some takeaways. Ticks are particular about their soil. If I learned anything from this project, their soil is important. So all these models did pull out ecological relevant covariates. All models were dominated by Longicornis, and we are again going to do this by species, but this was my first round to just see how these models performed if we gave them as many XY points as possible. MaxEnt, which was surprising, could actually handle these fine scale roster data, but it was at a cost. I think it took me per one of those maps like 4 hours to run, so and I have 5 more parks to do, so it's, you know, it's good, but just know it's computationally heavy. The GLMMs, they did what I expected them to do, and then they pulled out ecologically relevant maps as well as information. But I really found that the SPDE, especially because we could take that mesh and make it fine scale, had a little bit more detail of what I needed, I think, for my chapters. So bringing it back to that chaotic mess, maybe a little bit cleaner. Really, that chapter 2 was answering some of these questions. Where are the ticks? Where's the highest density of ticks? And then questing ticks and how landscape variables interact with them. But of course, I have these upcoming chapters next. The next one is that REST random encounter model that will look at the density of meso and deer populations in my chapter 2. And then a little bit of Carson's Masters is that seeker model for small mammal densities. And they're all feeding back to where are the ticks on the landscape. So some concluding thoughts, be clear with your ecological questions. Hopefully I proved to you that any of these models can work for species distributions, but depending on what you're actually doing and what detail you need for your species of choice, they depend. We are gonna do a formal model evaluation and comparison. So again, we're gonna withhold data, we're gonna make covariates exactly the same, and we're gonna see how each one of those perform, and if there's any of them that perform better or worse. Get published is, I think, everyone's goal here. From this, hopefully you can see that we have another paper that just popped up from doing these maps, and it's gonna be on Longicornis. And then finally, I'm just gonna take these results and apply them to my future chapters. So with that, thank you very much, everyone. This was a massive project. I had a lot of help from a lot of people from a lot of programs, and I will take any questions. Is it a soils question?
Maybe.
Okay.
Well, so I'm curious, I actually have 2 questions. The first is, in terms of distribution, you know, ticks, I mean, they're mobile, and so they can travel, but they can't travel very far.
Yes.
And so, like, I guess, how does that play in, I guess, to this model,
Yeah.
right?
That's a good question. So for this, for my chapter 1, what I really did was focus just ticks and landscape, because if they're traveling by themselves, they might go like a meter.
Right.
And so that's why we pulled out this. But what was interesting about the SPDE, it was showing me maybe a relationship now that wildlife comes in, and wildlife is their big dispersal unit.
Okay.
And so those 2 pieces, I'm going to try to answer in my chapter 3 of this giant relationship. If we can look at wildlife and then the landscape and then the ticks, and then see if we can look at changes of where they're going to be.
So a clarifying question on that, is it like they don't like an area and they're more likely to hitch a ride on the next?
If they choose or yeah.
Sure.
I think it's a mix of both. They either just
Okay.
die because they can't make it, Or if they're lucky enough and a wildlife species walks through, they'll hitch a ride on there. But they, at least for our native ticks, they just drop off, lay eggs there, and hope that it's the best. And there's some areas, like, they just hate wetlands because it's too wet. And I imagine if they accidentally drop off and lay eggs there, they just probably die. Yeah, or just give up.
And then my other question, not so much about your research, but I've had two of my neighbors comment to me recently that, oh, we had a really hard winter and now there won't be as many ticks.
Oh my God. I have exploded Jennifer's phone about how bad of a year of tick it's going to be because I just worked
Oh, this
on
is
it.
not good news for me.
Yeah, no, it's going to be a really bad year, everyone. Brace yourself. Yeah.
I know very little about the tick life cycle, so these questions are both related to that. So one, is there a phase where they live within the soil? And the second thing was, you had mentioned that the disease incidence, or their disease carrying capacity, whether the term would be, is increasing now, you're seeing more ticks. So what does that do to, is there a reservoir of diseases in an animal population that's increasing?
Yes. So to answer your first question about the soil, ticks, they rely on soil, I think, throughout their whole life. So when the eggs are down on the soil keeps them moist. The soil also just has that ambient like humidity and temperature that they find important. And for ticks themselves, temperature and humidity is number one. I think in all of those graphs too, they always had a positive relationship. So that's number one. So that's why soil is important. And I knew it was important, but actually seeing it now, I have to add it to all of my models. So if you have good soils data, let me know, because I just pulled that off the national thing. Okay. And then the second part of that question of diseases, yes, I didn't bring it up in this presentation specifically, but with wildlife species, especially white-footed mice, and other species like that, they are great reservoir species for a lot of diseases, and they love fragmented landscapes. So we're seeing a boom in those types of species. And then white-tailed deer, of course, they're exploding, and they're kind of this dispersal unit for all that. So those two interactions of a competent small mammal that's giving them all the disease, and then a big mammal that's bringing them everywhere, is just making it a perfect storm. Yeah. Do you have soil questions?
You're inviting me
Yeah.
questions. So Mike, you sort of alluded to this just a minute ago, but my first question is sort of, what was the source of your soils information?
I got it from, and I remembered it from the soils class I took. It's like the USGS SS.
Web soil survey?
Yeah. Is that okay?
So it's probably the best source in terms of what's generally broadly available.
You got better?
No, but they, their classification is pretty comprehensive.
Mm-hmm.
And so you've described the soils with their surface texture phase,
Oh, no.
which is, silt loam or
Yeah.
loam or sandy loam, but the information that's actually in the soil units is much more comprehensive. And so it
So like
could,
there are other attributes on that?
Yeah.
Yeah.
so the map units that are
Okay.
included on the maps include 100 attributes.
Okay.
And
Yeah.
so there may, you alluded to some of these things like drainage class, and wetland. That's included in the information, although it's not in the name
Yeah.
per se. So there may be other, maybe even more useful information than the texture that you might, maybe with a little enlightened examination, might be able to tease out of there.
Yeah, that is something when I pulled it in, I initially had I think it was the hydro something, and I saw it was like classes A, B, and C, and then immediately was like, I don't know.
Hydrologic
So I went with the one that I was like, I know kind of what this is without diving too much into it, but that's a good idea now that we know that silt loam is something they don't like, and then if it's truly wet, or how deep it goes, I guess, how wet it is.
There may be another way to classify the
Yeah, I
attribute,
think what
which
Mark
may
is
even
saying
be
is like read
stronger.
the metadata and actually understand what the other options are within
Okay.
the same spatial layer. Because there might be things that capture the tick ecology better.
Noted.
Cool.
Good note. Yeah.
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 So since you said that you used zero-inflated models, does that mean that while doing your transect, most of the time or most of the areas you have no ticks at all?
Yes, and so I'll actually go back to that picture. It's kind of hard to see, oh, sorry. this gives you headaches. Oh, so sorry. I thought it was a lot closer. Okay, for this, so I had to, and this is why I picked a zero inflated model, because I thought it would handle zeros more. Very much so, and like why this looks like a star is because how many zeros were in my data. And if you were to zoom in, you will see maybe around here, you'll see some points coming out, or I kept it in there, but I got rid of it, of where the true XYs are. And it's because of how clumped they are. So you can go to a site and never get a tick. You can go to a site and only get it in one location and the rest is zeros the whole time. Or you can go to a site and it's just completely inundated no matter where you go. And so I thought the zero inflated was the most appropriate to handle just the over dispersion and the amount of zeros. Does that kind of answer you? But yeah.
And one more question is that, is there any relationship between the, the density or the probability of distribution of the ticks, whatever species you take, with relationship to any mammalian community? And do you think incorporating those species in your model could change the your distribution of your ticks?
Yes, I definitely think it can. The reason we started with just the landscape and the ticks was to start at just the basics, because they do spend 90% of their time on the ground. But as I get into my chapter 2 and my chapter 3, that's a relationship that we hope to pull out, is if the wildlife community is there and it's the right perfect storm of a lot of deer and a lot of mice, are we seeing the distribution change in the landscape as well? And then therefore the pathogens as well. So, yeah.
Since ticks are, depending upon like high humidity environment and whatnot, I was wondering if you considered using more vegetation indices in your model, like NDVI or DVI, something like that?
We did consider it, and I was thinking about NDVI, and then we also did a leaf litter parameter, but that data, I think, what did I say on my slide? There was like 450 of those data sets that I have to go through and clean. And so when I get that leaf litter, I was thinking of having that as another parameter along with leaf litter to see if we can get at just, I guess, leaves and humidity on the ground.
And then a follow-up personal question.
Don't go outside.
What's the best way to get rid of ticks in your lawn?
Well, not including lawn and cornice, because I don't know what they're doing, but it seems like they like lawn. For our native species, they like that area that's right on the edge and with your leaf litter. So if they're in your lawn, you can either get some treatments and make a barrier where those like wooded areas are that I'm assuming are against your lawn. And they have them on Amazon. There's some that target specifically mice. Or you can make a barrier through the landscape itself and like really mow down the grass there so it comes out and there's like no moisture, not big grass, no leaf litter for them to kind of hide and be in, and just keep like this barrier of safety, I guess. Any more questions? Permethrin treat your pants, that's like that.
I see online people are using like little toilet paper.
Yeah, you can make them yourselves, yeah.
And then I did see that tick drag thing, and that's why I'm like, oh, I can cover that in duct tape.
That's true, it's so true, yeah.
Tick tubes are a long-term thing that you have to do.
Yes, yeah. You have a question?
Yeah, I mean, it's again more just about ticks in general and like kind of jumping off Dr. Art. So like you said, it's actually gonna be a really bad tick.
Yes, it is.
Why? Because I would have thought the cold too. So
So ticks have a 4-year life cycle, and I think that plays into it. And so depending on where we are in the cycle, you'll see a boom. So right now, I think from tick sampling 2 years, and this is very like anecdote, me just seeing what's in the field. The first year I did this project, we had very low tick numbers. The second year exploded. And then this year, just being out in the field and doing field work and looking at some of the mammals, I was on a deer trapping project, and also Travis heard me say this nonstop. The ticks were just abundant, and specifically the Lone Star ticks, which I've never seen at that amount of level, and then the Longicornis ticks. So I think just because we're generally warmer each year, And I go off of the Cherry Blossom Festival as a tracker of climate change, essentially. The ticks, we had some cold fronts, but I don't think it was enough to really get rid of them. And then we're seeing just this expansion of 2 very aggressive ticks. So, yeah, sorry. Sorry, everyone. Any more questions? Oh, yes.
I would just say I feel kind of itchy.
Yeah. Do you want to look at my picture?
I keep going like this, and I keep thinking that there's a tick on me, but I go mostly in wetlands. I can tell you, it's not many. It's really
Perfect.
woods going into the wetlands where I get them, the dry woods, going to the wetland, and I'm like, you can live in the wetland, there's no tick.
Yeah, exactly.
But in salt marshes where lime ticks came out, there's a lot of salt marshes there. Do they live in salt marshes?
No.
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 Or somewhere else.
There, it was, I think Lyme, Connecticut is literally in the wooded, like, where, like, they have a tree festival too. That's not, yeah. Yeah, anything, when we talked about it a little bit more as we were looking at the soil, I think it's a happy medium, like sandy being the most, that drains the most, which is, might be too much, not holding humidity from my bare minimum soil, and then going up from there. So they're in this happy medium of it's enough to hold some moisture, but then not pool, no clay. Any more questions?